And be careful with touching the dry ice. And get another piece, put it alongside it. Okay, now put that piece, flip it over, and fit it so it doesn't have any room on it. Yeah, so it's secure to the base. There you go. All right.
Take them off.
Yeah. I'm gonna put up.
Go. Now, hello, my name is Kayla Jones, and I am in 7th grade, Miss Jones's class, 5th mod in 7th grade. Hey, now, what I'm doing for you today is a cloud chamber. now this experiment is for my science fair project tomorrow, and I hope you like it. So, here, as you can see, I put in the dry ice over the baking tray and the cookie sheet, and then put the baking tray all over it. As you can see, the dry ice is already burning through. So let's hurry up before it starts burning through. So here are the installation gloves. As you see, they're a little bit too big for me, but they can protect you from dry ice, because dry ice is not like regular ice. It can burn through your flesh and skin, and you don't want that. So now,
Go.
Now, let's take our radiation source. Now, my radiation source for this project, you've seen a lot of cloud chamber videos that use different radiation source, but mine's going to be uranium. This one was from a science lab. So I'm going to take a couple samples of uranium onto the baking tray. That's enough? Alright, and now we're just going to close this because we don't really know a lot about radiation rocks, even though I don't know. But radiation rocks, we need to be careful. That's why I'm wearing these gloves too. Not just for dry ice, for the sample of our radiation rock, uranium. Now we put the top on. Alright, now I put my small, I don't know if you can see it.
Put up.
Huh? Alright, so now we have our little sample of uranium. Now, I'm here to show you a big chunk of uranium. And then the reason why you don't want these lost is because radiation we don't know how dangerous it is. So, we protect ourselves with these gloves to just make sure that our samples won't get too out of whack. Okay, now we're getting ready to put the cloud chamber's top on. So we don't need the gloves because we're not dealing with anything really too violent to our skin. So we're carefully flipping it over. Carefully. And placing it like so, right onto the baking pan, trapping the uranium. And to make sure, we have duct tape, black duct tape. Or you could get any type of duct tape just as long as it's strong enough to hold it. So now I'm getting ready to seal the top to our cloud chamber so then that no air can come out. Welcome back. Welcome back. I have finished making and building the cloud chamber and also airtight sealing it. And as you can see, while I was building, the ice had time to burn through. Now, in order for this to work, we need a room that could become very dark, and also a warm bowl of water, and an LED light. If you want to try this at home, then I'm using a fish tank. So it came with a light. Then we can see what's going on in it. All right, let's make it happen. Now as I turn. Now I'll turn on the light and let the magic happen. Now, this project takes patience.
You already see them.
And as you can see, you can already see the lines starting to happen. Because the more dry ice you have, and if you have radiation, as you can see, it will start becoming active already. Just to let you know, these lines here are radiation paths that the radiation makes when it shoots all over the place. So that's why we have the top on, then it can stay in there.
Oh, that's a nice one. That's in a nice one.
So this experiment is going along nicely. Now, why I did this experiment is because, not just because I want to do it, but this is giving us a chance to actually see atoms with the naked eye. Now the normal way, today way that people will see atoms is with the microscope, because you can't really see the atoms with the naked eye. So this experiment is like making your own homemade microscope. Only it's a cloud chamber. So these smoke lines are not like smoke. It's just radiation slashing through the mist. That's why it's called particles in the mist. So now we are at the stage of atoms decaying. They are falling apart. Now atoms, you might not think atoms will like decay or fall apart because you can't see them. But then now, since you can see them, you can actually see what activities like bouncing around in there. And it's from the power of radiation and the dry ice working together to make this happen. So now I'm pretty sure you guys are wondering why there's condensation happening. Well, this is not water. This is isopropyl alcohol, and also radiation clashing together to make the lines appear. Here, so if there was like one missing, the lines wouldn't appear. Like if radiation was missing and you have isopropyl alcohol, it wouldn't appear like that. And if you have isopropyl alcohol, and if you have no isopropyl alcohol and have radiation, it wouldn't happen like instantly.
Go.
All right. So we don't have any more radiation activity. So again, thank you for watching this third experiment. This is my third experiment for my cloud chamber, particles in the mist project. And I will come back to you with my fourth experiment when I'm ready. So again, Kayla Jones, in 7th grade, and I hope you liked this experiment, and I hope you'll try this at home. Thank you.